So Hala, you can see the screen, right?
Yes, sir.
So the worksheets we pasted, we'll start doing those as well. But the basic idea so far that we covered was that you've got electrodes, right? And electrodes have potential if the substance likes to lose electrons, so it's going to produce a lot of electrons on the electrode, and the potential on the electrode would be very negatively charged. And if the substance likes to gain electron, then it's going to the electrode over there would become positively charged. It's going to have a higher potential, right? So what you're going to do is you're going to connect two electrodes together, right? And once you once you do that, electrons flow from the lower potential to the higher potential. The lower potential is the one that's going to lose electrons. It had a lower potential, which basically meant that it had this tendency to lose electrons. And the one that has the higher potential, the reason it had the higher potential was that it had this tendency to actually gain electrons, right? So you will start a reaction, and instead of a reversible reaction, the reaction is going to go in one direction now. Here, one side would lose electrons, the lower potential, and the higher potential is the one that's going to gain electrons, right? So अब फिर मैंने वो सॉल्व ब्रिज वगैरह सारा डिस्कस किया था and then I told you that you can simply directly, instead of drawing the whole diagram, you can pick the two electrodes that are given in the data booklet and connect any two electrodes together. The higher potential is the one that's going to gain electrons, and the lower potential is the one that's going to lose electrons, right? So higher the electron gain and the lower would start to lose electrons. And you can make the overall equation by adding up the reactants. In each case, where the reactants are on the left side because it's going in the forward direction, and the other one is getting oxidized, so the reactants are on the right side. So what you can do is you can add up the reactants and the products, and you'll come up with the overall equation, which you can see over here. So, but you have to make the electrons gain and lost equal. So you pick any two electrodes without drawing the diagram. You can figure out what type of reaction would happen, who would gain electron and who would lose electrons. और इसमें ये कि the E naught cell is the potential of the cell, which is the potential difference between the two electrodes. That kind of indicates how quickly the electrons would flow from one side to the other. So the bigger the E naught cell, the faster is going to be the reaction. It's the higher potential. But the potential difference क्या होता है? It's higher potential minus the lower potential. So it's basically the reduction E naught minus the oxidation E naught. Higher वाला gain कर रहा होता, so that's why it's the reduction E naught. और lower वाला जो है ना, that's ये वाला higher वाला जो था, that's totally the reduction E naught, and the lower one is the oxidation E naught. ठीक है? तो और E naught cell अगर greater than 0 है, that means the reaction is feasible. अगर zero होगा ना, तो उसका मतलब है कि कुछ भी नहीं होगा, ठीक है? The electrons will not flow. याद है, clear है? उमर clear है? हाल is clear.
Yes, sir.
तो इसी तरह ना इसको I'm just going to pick एक दो किधर डेटा बुकलेट एक सेकंड. So remember, I can pick any two electrodes and I can do exactly the same. ये वाला इन दोनों का देख लेते हैं, Fe2 plus Fe3 plus और iodine वाला, ठीक है? वो देख लेंगे what is the reaction. I'm just going to copy that. तो ये एक और करें. So I've got Fe3 plus electron and it's in equilibrium. और वो in equilibrium with, I mean that's 0.77 volts, ठीक है? और वो जो iodine वाला था ना, that was iodine plus 2 electrons, and it was in equilibrium with 2i minus 1. And the E naught is 0.54 volts. तो बैठ के ना इन दोनों का रिएक्शन बन जाएगा. इलेक्ट्रॉन कौन गेन करेगा? द हायर वन इज द वन that's going to gain electrons. और वो जो lower है, that's the one that's going to lose electrons. ठीक है? And you'll just, it's very simple. You just figure out this and that's about it. ठीक है? बाकी सिर्फ क्या रहेगा? You have to make the overall equation. You have to make the number of electrons gained and lost equal. So that's at the moment not equal. तो इसको 2 से multiply कर लो so that the electrons are now equal. ठीक है? And then you add up the reactants. तो ऊपर वाले में the first one, the reactant is ये वाले left वाले. ठीक है? और नीचे वाले में the reactants are right side वाले. ठीक है? Because it's going in the backward direction. So I'm going to add up the reactants. It's 2Fe3 plus. And नीचे वाले में the reactant is 2I minus 1. And the product is ऊपर वाले में it's 2Fe2 plus. Or the other product is I2, right? And that's it. ठीक है? That's your, तो ये हमारी ना overall equation बन गई. ठीक है? क्लियर है सारों को? मिडिल, उमर, हाला, is this clear?
Yes. Yes, sir.
और इसका ना E naught cell we can calculate. It's the reduction higher minus lower. ये reduction potential minus reduction electron gain कौन कर रहा है? ये पहला वाला. lose कौन कर रहा है? oxidation potential. ठीक है? तो reduction potential minus oxidation potential, so it's 0.77 minus 0.54, and that comes out to be 0.23 volts, जो कि काफी कम है, very close to zero, but the reaction will still be feasible. It will happen, but it will be kind of a slow reaction. सही है? एक वो कर लेते हैं जो रिएक्शन में पता है कि the reactions that are very fast. The sodium or chlorine reaction, जो ना, sodium is very reactive, chlorine is very reactive, so that reaction would be very fast. दोनों की जो values है ना, वो यहाँ से कॉपी कर लेते हैं कि क्लोरीन ना Cl में होगा. इट्स ये क्लोरीन है. ठीक है? 2Cl minus 1 1.36 volts, राइट? और इसी तरह ना सोडियम जो है ना, पता नहीं क्या है सोडियम पर कहीं होता था. एक सेकेंड, ये आ गया था. अच्छा, 1 सेकेंड. अच्छा, सोडियम जो है ना वो यहाँ पे किधर गया? ये. ठीक है? प्लस अब आई नो कि रिएक्शन इज sodium and chlorine reaction is very spontaneous. It's going to be very fast. Both are very reactive. तो इधर से प्रूव भी कर लेते हैं कि एक तो ये हो गया. This I think was minus 0.27 volts. And the other one was the chlorine one. That was 2 electrons, Cl minus 1. E naught was 1.36 volts. So higher would be the one that would gain electrons. So it's the electron gain karna hai, and the lower one is the one that's going to lose electrons. So that's going to go. So ये lower hai, and this is your higher. अच्छा, और बाकी ये कि just give me 1 second. अच्छा, the rest is that all you have to do now is you have to make the electrons equal to. This will be now one attack. I'm going to put, I'm going to make it 2, and this is 2 as well, right? Now what you're going to do is you're going to add up the reactants. कहाँ पे reactants? ये वाला. And add up the reactants which are these, right? So I'm just going to do that in one step. So 2 sodiums, or नीचे के it's chlorine, and the product is ऊपर वाले में it's 2Na plus 1. और नीचे वाले में it's 2Cl minus 1. Okay, so you're getting NaCl, right? This is what you predicted when sodium reacts with Cl. ठीक है, ये दो आपके products थे, so I wrote the products together. The electrons would get cancelled out, and look at the E naught cell now. I mean, if you look at the E naught cell, it's going to be reduction potential minus your oxidation potential. ठीक है, so the गलत कर दिए, reduction नीचे वाला है 1.36 minus by oxidation potential, which is minus 2.71. तो इसको देखो क्या आएगा, it's going to be a big value. It's going to be 4.07 volts. ठीक है, is this clear?
Yes.
Umar, clear है? Mama, is this clear?
Yes, sir.
अच्छा, so that's it. ठीक है, अच्छा, now things, अब ये basic idea. ठीक है, higher potential gains electrons, lower potential is the one that loses electrons. अब ये कि things will get slightly more complicated, right? Because the actual reaction में ना, no one gives you कि भी कौन सा electrode है. मतलब कोई reaction हो रहा है ना, they don't tell you what the electrode is, right? So for example, I have a reaction or social FeCl3. अच्छा. So remember, in an actual reaction, they don't tell you or they don't specify what the electrode is. So for example, तो ये थोड़ा सा complicated होगा, but it's the same concept, exactly same thing, ठीक है? अच्छा, तो actual reaction में they're just going to tell you the copper reacts with FeCl3 aqueous, and they're asking what's going to happen. Now, it's not going to be that straightforward, क्योंकि if you look at the data booklet, you don't have an electrode for FeCl3, ठीक है? मतलब FeCl3 का electrode नहीं है, Cl का अलग electrode है, ठीक है? मतलब if you look at the data booklet, तो कहाँ गया Fe? अच्छा, Fe के ना ढेर सारे electrodes हैं. There's Fe3 plus, ठीक है? There is Fe3 plus, and that could gain 3 electrons and form Fe. That's one possibility. Fe3 plus could gain 1 electron, and that could form Fe2 plus. So there are multiple possibilities now. There are multiple possible electrodes for this reaction. Copper का भी ना, copper दिया हुआ है ना. Copper could be turning into copper 2 plus, 1 plus. Copper could also possibly turn into copper 2 plus as well. So copper की you got 2 electrodes. ऊपर से Cl भी है, Cl के भी electrodes होंगे. So the point is, in an actual reaction, you don't have just 2 electrodes, you have a lot of electrodes, and out of all those electrodes, you have to figure out which ones are the most likely of them, okay, that will undergo a reaction. So पहले तो step number 1 now, you have to identify your reactants. So you have to be clear that the reactants in the above equation is copper. Ionic compound, we're going to treat them as separate ions. Fe would be C plus, and you got another reactant which is Cl minus 1. Now, these are your reactants. You're not going to look at, मतलब कोई ऐसी equation नहीं देखनी. You're not going to look at equations of Fe2 plus or Fe, because your reactant is Fe3 plus. You're trying to figure out, okay, what happens to Fe3 plus, or what happens to Cl minus 1, or what happens to copper. So remember, you're not looking for reactions of copper plus 1. You're not looking for reactions of copper 2 plus. ये जो है ना यहाँ पे, you're only going to consider reactions that involve these three. ठीक है? So second step जो होगा ना, that is, you're going to identify all electrodes and only those electrodes. So all possible electrode reactions involving your reactants. Okay, that is what you're going to do. So for example, I'm going to start looking for copper, but only copper. Copper को क्या होगा? So if I go back और data booklet open करूँ ना तो what I'm going to see is कि copper कहाँ है? Copper is over here. Okay, so that's one possible electrode reaction. Copper is also in this second electrode, right? So that's another possible electrode reaction. I say इस वाले को ignore करो because it doesn't have copper. So since I was looking for reactions of copper, so the third one has no copper, right? I'm going to ignore the fourth one as well, because although it has copper, लेकिन it's copper reacting with ammonia. We don't, मतलब हमारे पास ammonia नहीं है. We don't have ammonia, so this reaction does not apply in our case. ठीक है, ammonia होता तो मैं copper plus ammonia consider करता, लेकिन there is no ammonia, right? So I'm going to leave that one out as well. So copper can I have identified 2.52 or 0.34, right? So नहीं, sorry, copper की मैंने सही आइडेंटिफाई किया, इससे गलत नहीं किया. अच्छा हाँ ठीक है. इससे देख सकते हैं इसके. अच्छा, so for copper, what I have is एक था copper +1 plus electron. अच्छा, remember the reactant that you're looking for, वो right side पे भी हो सकता है, left side पे भी हो सकता है. We don't really care because we don't know whether it's going to lose electrons, whether it's going to gain electrons. So I'm open to all possibilities at the moment. ठीक है. अच्छा, वो दूसरा क्या था? That was copper +2 plus 2 electrons. और copper इसका मुझे याद है 0.34. वो मेरे ख्याल से E naught was 0.15 volts. एक दफा confirm कर ले. So you had 3.34 by 0.52 था. 0.52. This was 0.52. अच्छा, similarly, I'm gonna look for Fe3 plus reactions. तो but only Fe3 plus. तो मैं जाके ना वहाँ पे देखूँ. If I'm gonna look for Fe3 plus only, ठीक है. So any electrode that involves एक ही है Fe3 plus आ रहा है इसमें. So there are two possible reactions. Fe3 plus could gain 3 electrons, could gain 1 electron. Or कहीं है Fe3 plus. I don't think there is Fe3 plus anywhere else. So minus 0.04 or minus 0.77. So I'm going to write those reactions. And then you had another one, Fe3 plus 1 electron, and it was forming. So it was forming Fe2 plus. And this value was 0.77 volts. ठीक है, तो मैंने सारे possible reactions देख लिए. I'm going to just underline those. I was looking for what's happening to copper. What could possibly happen to Fe3 plus? So अभी नहीं मुझे पता कि क्या होना है. I'm just writing the reactions. So the last one is Cl minus 1. So let's find out what could happen to Cl minus 1 as well. तो एक तो खैर वैसे डायरेक्टली कॉपी कर लेते हैं. अच्छा, एक है क्या, I've got Cl2 plus 2 electrons. And the E naught was 1.36 volts, because में Cl minus 1 आ रहा है, ठीक है, so I wrote this down. अच्छा, is there any other reaction that involves, अभी ये थोड़ा टाइम की प्रिंटेड होगी, ठीक है, साथ ही ना. अच्छा, so अच्छा एक तो ये हो गया. There is another reaction that involves electrode reaction that involves Cl minus 1, but लेकिन उसके साथ Cl minus 1 is reacting with plus 2 OH ions. We don't have OH ions, right? So I'm going to ignore that one as well. I'm just going to pick this one. ठीक है, that's the only one that has Cl minus 1 in it. तो ये मैंने उसमें से ना सारी अच्छा, ये आपको दोबारा लिखने की जरूरत नहीं है क्योंकि वो साथ प्रिंटेड होगी. यू कैन डू ऑल द वर्क, मतलब उसी के ऊपर टिक लगा लो. यू कैन डू इट इन ऑन द पेज दैट इज प्रोवाइडेड. ठीक है. अच्छा, अब so we've identified all the electrode reactions, right? There again, Ala, Mawa, Muhammad, is this clear? Middle clear है?
Yes, sir.
The third step. अब इनमें से ना, I'm going to look for the highest E naught. Remember, what did we learn? कि highest E naught जिसका होगा ना, that's the one that's going to gain electron. So the possible reactions हैं. The one who has the highest E naught is the one that's going to gain electron, and the lowest E naught is the one that loses electrons. But you have to be careful about one thing. जो भी select करो ना, it should be your reactants that are gaining, or make sure that your reactants are the ones that are gaining or losing electrons. कोई चौथी चीज आ गई ना, so we're not going to count that. So make sure that your reactants are the ones gaining or losing electrons. और reactants कौन से थे? जो मैंने underline किए हुए top में, copper Fe3 plus Cl minus 1. So highest is the one. So these are the possible reactions. Highest is the one that's going to gain electrons. Lowest is the one that's going to lose electrons. तो पहले figure out कर लेते हैं. इनमें से ना, who's the one that's going to gain electrons? तो highest कौन है इसमें? Highest जो है वो सबसे bottom वाला है, 1.36, right? So in all our 5 reactions, the greatest density to gain electrons is for the last one, 1.36 volts. But the issue is कि अगर मैं उसको select करता हूँ ना, तो it's actually Cl2 that gains electrons. And हमारे reactants में ना, if you look at the reactants, so there is no Cl2. मतलब यहाँ पे Cl2 तो मेरे पास कहीं भी नहीं है. So the point is, okay, it's Cl2 that gains electrons. It has the greatest density, but since we don't have Cl2, तो मसला ये कि इस reaction में कोई फायदा नहीं है. It doesn't really apply to our, ये जो ऊपर वाली तीन है, it doesn't really apply to it. वो लिख मैंने इसलिए दिया था because it had Cl minus 1 involved, but the Cl minus 1 is being produced. It's यहाँ पे Cl minus 1 is one of the reactants, right? So which is why I'm not going to count this one. तो इसको मैं ignore कर रहा हूँ, and I'm not going to use that. उसको हटा के, which one is the highest potential now? It's this one, 0.77. So this is the one that gains electrons. हाँ, आप इसको देखो तो मतलब बाकी 4 में ना, the highest density to gain electron is for Fe3 plus. Or we do have Fe3 plus. Fe3 plus is one of our reactants, right? So that means कि ये सही है. This is the one that is the one, मतलब जो ऊपर तीन है ना, इन तीनों में, highest density to gain electrons किसकी है? That's Fe3 plus, right? तो ये जो bottom वाली है, I've ignored that, ठीक है, because I didn't have Cl2. But Fe3 plus is fine. That's the one that's got the, एक तो वो highest भी है plus वो Fe3 plus है उसमें, ठीक है. ये clear है सारों को?
Yes.
Clear है? Very clear. Super clear. Middle, Mava, Hala, is this clear?
Yes, sir.
अच्छा, वही काम ना उल्टा करना. We're going to find the lowest one. The lowest one is the one that's going to lose electrons, right? So this is actually minus 0.04 volts. अच्छा, lowest जो है ना, minus 0.04 volts है, ठीक है? So that is the one that's going to lose electrons, right? So it's going to go backwards. It's going to lose electrons. But again, the problem is कि lose कर कौन रहा है? It's Fe that's losing electrons. और हमारे पास यहाँ पे there is no Fe. We have Fe3 plus, we don't have Fe. The point is, although this is the lowest, but since we don't have Fe, I'm just going to ignore this one. ठीक है? I'm not going to use this one. इसको हटा के, which one is the lowest one? The lowest one is वो इससे ऊपर वाला है, ठीक है? That's the lowest one. And so copper is the one that's going to lose electrons. And if I look for copper losing electrons, so I do have copper over here, okay? So copper is the one that loses electrons. So ठीक है, इसमें कोई मसला नहीं. This is the lowest. We found out the lowest. And there's nothing wrong with this. ठीक है, this is fine. And that's by lowest E naught, ठीक है? तो और इसको highlight भी कर लेते हैं दोनों को कि so that's one electrode reaction and the other one is this one. अच्छा, point is कि आपने दोबारा लिखना तो नहीं है, लेकिन in your data booklet what you're going to do is कि इन तीनों से related ना जो भी equations है ना, you're going to mark those, ठीक है? And then you have to find which one gains electrons, which one loses electrons. So the one that has the highest potential, that's the one that gains electrons, ठीक है? That goes forward, and the one that has the lowest potential, that's the one that's going to lose electrons, ठीक है? That's it. Except कि you're going to ignore all the other equations which the highest ये था, लेकिन ignore क्यों किया? क्योंकि Cl2 gains electrons, but we don't have Cl2. ऊपर Cl2 लिखा ही नहीं है, तो how would it gain electrons? The lowest was this one, but it was Fe that loses electrons, and since we didn't have Fe, so I just ignored that equation as well. तो काम मैंने वही किए, except के वो जो lowest और highest find out करना था ना, जो पिछला केस था ना, उसमें they gave you electrode reactions. यहाँ पे they just gave you substances, random substances. किसी भी एक reaction में you can have many substances. तो उन सारे substances में से ना, you have to sort of figure out इनमें से which one is the one that's going to gain electrons and which one is the one that's going to lose electrons. So this is how you're going to do that, and you can then make the overall equation. जैसे इनको use करते हैं ना, फिर आप overall equation देख लो. Electrons balance होने चाहिए. So what I'm going to do is I'm going to ये Fe वाली को ना 2 से multiply कर रहा हूँ. 2 और 2 ताकि electrons gain and loss equal हो जाए. And then I'm just going to add the two equations up. So reactants में कौन सा है? It's copper. उधर 2Fe3 plus. Products में कौन है? It's copper plus 2. Plus 2Fe2 plus, right? So those are your products. And you can, उसी तरीके से ना, you can calculate the E naught cell. Or reduction E naught minus oxidation E naught 0.77 minus 0.34, and that gives you कितना होगा? 43. Yeah, that's going to give you 0.43 volts, which makes the reaction feasible. So remember, if you're lucky if they give you the electrode reactions directly, okay, then you're lucky. You just have to go higher gains, lower losers. That's it. If they gave you just random substances, so थोड़े steps ज़्यादा हो जाएंगे, ठीक है? You would have to look for all possible reactions. So ये clear है? सारों को clear है कि clear?
Yes.
So I'm just going to do another similar reaction. Okay. थोड़ा सा सिंपल कर लेते हैं कि Cl2 plus KBr. अच्छा, इस केस में ना, so remember your reactants are, first thing, identify your reactants. Your reactants are Cl2. Ions को separately treat करना है, K+1 and Br -1. I'm going to open the data booklet and I'm going to write all possible reactions involving these three. ठीक है? तो पिछले वाले रखो देते हो. अच्छा, वो Cl2 वाला तो वही है, ठीक है, which we already discussed. ठीक है, this is Cl2. Br2b, yeah, Br minus 1 is this, right? So that's there. और कौन सा था? K plus 1 था. K plus 1 भी इधर ही कहीं था वो. इधर K plus 1 ही है. ठीक है, so I've got a reaction of K plus 1 that's minus 2.92 volts. इनकी values में याद रख लो. Cl2 1.36, Br 1.0. अच्छा, वो 1.07. So copy those. So this one is 1.36 volts. K plus 1 वाली क्या है? That's 1 electron. And that E naught is minus 2.92 volts. And Br2 1.07 था plus 2 electrons. And 2 Br minus 1 and the E naught is 1.07 volts. Okay. Okay, so now these are the three possible cases. In Saname, who gains electrons? The one that has the highest potential. Okay, so this is the one that's the highest potential. It is the one that's going to gain electrons. And should I use that? Cl2 is the one that's gaining electrons. We do have Cl2 though. But again, phenomena it's Cl2 that has the greatest tendency to gain electrons. और फिर वो फिर lose कौन कर रहा है? So at the moment it's this is the lowest potential. This is the one that loses electrons. But we've got a problem. Okay, although it is the lowest potential, it has the greatest tendency to actually lose electrons. लेकिन lose कर कौन रहा है? Potassium lose कर रहा है. और मेरे reactants में I don't have potassium. I have potassium ions, but potassium नहीं है मेरे पास. ठीक है? So which is why I'm not going to use this. ठीक है? That's मतलब ठीक है, वो सबसे ज़्यादा tendency उसी की है lose करने की. But there is no potassium, right? फिर आप बाकी तीनों में से इसको हटा के which one is the lowest one? That's वो फिर ये वाला lowest. So Br minus 1 is the one that loses electrons. Do we have Br minus 1 in my reactants? I do have Br minus 1 in my reactants. ठीक है? तो ये चल जाएगा. So that's my lowest. और बस reaction पता लग गया. That's क्या होगा reaction? It's electrons be equal. So I'm going to add up the reactants. ये reactant और ये reactant. And I'm going to add up the products. So ये product and this product. So it's Cl2 plus 2Br minus 1. And the product is limit 2Cl minus 1 and the नीचे वाला में it's Br2. So that's my redox reaction that's going to happen. And this is the ionic equation. Remember, K is a spectator, right? Nothing is happening to K. K वैसी फालतू में बैठा हुआ, it's nothing is going on with K. K is just a spectator, right? ठीक है? मैं लिख भी देता हूँ, that's your spectator. Nothing happens to it. और ये आपके पास इसका E naught cell निकालना है. You can calculate the E naught cell, which is going to be the reduction potential minus the oxidation potential, which is 0.19. 20 करो तो 27. 29, sorry. ये सही है, ये क्लियर है?
Yes, sir.
पासवर्ड मैंने सेंड किया उसमें ग्रुप में. एक सेकंड. One of them is solved. जो that's unsolved, ठीक है, ये unsolved. तो इसमें मेन चैप्टर जो है ना, वो मेन जो चीज है वो हमने कवर कर ली है, ठीक है. The rest that is left अभी तो खाली जो भी हमने किया ना, I'm just going to do questions related to that. चलो ठीक है, स्टार्ट से ही कर लेते हैं. अच्छा, so starting with question number 1. अच्छा, इसमें ना सही से मेरा भी स्क्रीन स्टार्ट हो गया, टैबलेट डिस्कनेक्ट हो गया. चलिए, अभी टाइम भी कम है, थोड़ा सा एक आध सिंपल क्वेश्चन कर लेते हैं कि इस पे टाइम लग जाना. अच्छा, ये वाला कर लेते हैं. वो कह रहे हैं यूज द डेटा बुकलेट टू प्रेडिक्ट. अच्छा, वो कह रहे हैं कि व्हाट्स गोइंग टू हैपन अगर एसिडिफाइड आयोडेट 5 आयंस और उसकी ना इक्वेशन ही गिव दिस इक्वेशन ओवर हियर, iodate 5 ions, right? And the bromide ions are mixed. What's going to happen? तो bromide ions की equation अभी हमने लिखी भी थी. वो क्या थी? Br2 plus 2 electrons from the data booklet. So what was it? It was forming 2Br minus 1, और मेरे ख्याल से उसका जो E naught था, we just did that. 1.07 volts था, ठीक है? So we have to figure out, predict whether the reaction is feasible and explain your answer. So higher potential is the one that gains electrons, right? It's this. And lower potential is the one that loses electrons, right? So, और वो electrons ना equal होने चाहिए. So I think वो iodate वाली जो equation है ना, that needs to be multiplied by 2. और ये वाली जो equation है, all of it, that needs to be multiplied by 5. I'm going to, although he's not asking for the whole equation, I'm just going to write the equation anyways. So reactant कौन से? It's 10Br minus 1. ठीक है, और दूसरा reactant कौन सा नीचे? It's 2IO3 minus 1 plus I think 12H plus 1 भी बीच में आ रहे हैं, ठीक है. And what are the products? The products, the first one is 5Br2. And the product in the second one is I2 हो गया, or 2 into 3, 6H2. ठीक है. So that's my reaction. लेकिन nowhere did he ask for the reaction. वो feasibility पूछा कि is it feasible or not? Which it is, because they are reacting together. Br minus 1 and IOC minus 1 are reacting together. But when he says कि भाई वो feasible है कि नहीं feasible, तो उसमें ना आप you have to calculate the E naught cell. एक mark इसीलिए क्योंकि he's not asking for the equation. So E naught cell here, that's the reduction potential, which is 1.19, minus the oxidation potential, which is 1.07. And you're going to get क्या था ये 190712.
0.12.
हाँ. तो इसके अंदर क्या हुआ? What you're getting is कि आपने बस बताना है भाई उसका जो E0 सेल है ना दैट्स ग्रेटर देन 0, सो हेंस इट्स फीजिबल। तो उसने बस ये जो ब्लू में मैंने लिखा है ना दैट्स द 1 मार्क आंसर। ही वाजंट आस्किंग फॉर द होल इक्वेशन, ठीक है। तो उसने कहीं भी नहीं कहा था 1 मार्क, ही जस्ट हैड टू टेल देम कि इट इज फीजिबल, ठीक है। ये क्लियर है?
Yes.
सिर्फ ये, इसका सिर्फ ये आंसर था। तो चलो ठीक है, बाकी क्वेश्चंस तो टाइम लेंगे, फिर हम नेक्स्ट क्लास में करते हैं। जस्ट रिमेंबर कि 80-90% चैप्टर जो है ना वो खत्म हो गया, मतलब वो यही है 80-90% चैप्टर। बाकी जो है ना दैट्स इलेक्ट्रोलिसिस और वो सारा ना वो फिर हम बाद में कर लेंगे। विल डू पास पेपर्स, ठीक है। उसके बाद विल डू द रेस्ट ऑफ द 10-20%, ठीक है। तो वो फिर कल करते हैं कंटिन्यू, ठीक है। चलिए, ओके एवरीवन, ठीक है, अल्लाह हाफिज़।